Hello, today I'll be doing chapter 10, Math in a Box. It's right here. Alright, let's get started. Suppose you have a piece of cardboard with length 32 inches and width 20 inches, and you want to use it to create a box. You'll need to cut a square out of each corner of the cardboard so you can fold the edges up. But what size square should you cut? Cutting a small square will make a shorter box. Cutting a large square will make a taller box. Look at the diagram below, and it's right here on the side. So, jumping to number 1, since we haven't determined the size of the square to cut from each corner, let the side length of the square be represented by the variable x. Write a simplified polynomial expression in x, and note the degree of the polynomial for each of the following geometric concepts. So for A, the length of the base of the box once the corners are cut out. My equation was 32 minus 2x inches. And that is because the length here is clearly shown as 32 inches, and the minus 2x is from the x on this end that's cut off, and the other end x cut off. Letter B, the width of the base of the box once the corners are cut out. Same thing, I'm taking the width over here, which is the vertical line here. It's 20 inches, and there's 2 x's to cut out too. So the equation is 20 minus 2x inches. The height of the box we don't know, so we're just gonna put it as x for now, because that's what we're cutting out. For D, the perimeter of the base of the box. Perimeter is P equals 2L plus 2W, and the two lengths are 32 minus 2x inches and 20 minus 2x inches. So we just multiply that by 2, and we should get our perimeter. The area is length times width, which is here. 32 minus 2x inches times 20 minus 2x inches. And volume of a box, that's length times width times height. So that's 32 minus 2x inches times 20 minus 2x inches times x inches. For number 2, evaluate the volume expression for the following values of x. Be sure to include the units of measurements. So, just a reminder, our volume equation is 32 minus 2x inches times 20 minus 2x inches times x inches. And on the side in yellow highlighted, are the values of x that they're wanting us to find. So, if x equals 1, if we plug in 1, the answer becomes 540 inches cubed. If it's 2, we get 896 inches cubed. If it's 3, it's 1092 inches cubed. 3.5, 1137.5 inches cubed. If it's 6, 960 inches cubed. And 7, 756 inches cubed. Now, based on your volume calculations for the different values of x in problem 2, if you're trying to maximize the volume of the box, between what two values of x do you think the maximum will be? So, I would say between 3.5 and 6. Why is that? It's because we can clearly see from 1 to 3 to 3.5, it's constantly increasing the volume, the size. It hasn't hit its maximum yet. But sometime between 3.5 and 6, it actually started decreasing. That means it hit its maximum somewhere between those two numbers. Now, number 4. Using trial and error, see if you can determine the side length x of the square that maximizes the volume of the box. And the hint they provided was it will be a value in the interval from problem 3. So we clearly know that it's between 3.5 and 6. So I decided to get a bigger number head start. I decided to go 3.9 right off the jump and end with 5. Thankfully that this guess of mine actually worked out, but if I plug in 3.9, it's 1151.436 inches cubed. If I plug in 4, it's 1152 inches cubed. 4.1, 1151.444 inches cubed. 4.2, 1149.792 inches cubed. 4.3, 1147.068 inches cubed. 4.5, 1138.5 inches cubed. And lastly 5, it's 1100 inches cubed. So we can clearly see from this table that I provided that x equals 4 gives us the maximum volume of the box. So, number 5, using the value you found for x in problem 4, Determine the dimensions of the box that maximizes its volume. So now we know what x is. X equals 4 inches. Now if we go back up, we remember that length and width. The length equation was 32 minus 2x inches, and the width was 20 minus 2x inches. Now we scroll back down. If we plug in x as 4, so for the length equation, it becomes 32 minus 2 times 4 equals 24 inches. Same thing with the width. We plug in 4, it's 20 minus 2 times 4 equals 12 inches. And because height is still the same, height equals x, and x we already found, x equals 4, so it's just 4 inches then. Now number 6, calculate the volume of the box in problem 5. So, volume. We already did this in problem 4 when we did the chart and everything, but we'll do it again here. Volume is length times width times height. And if we get rid of all these fancy equations, all we take is our length times width times height. It's 24 inches for the length, 12 inches for the width, and 4 inches for the height. And we get our answer again, 1,152 inches cubed. Okay, this is my own original problem now. If the original dimensions were not 32 by 20, and were instead 50 by 38, given everything else in the problem was the same, what would be the new max volume of this rectangle? So, back to it. Length is 50 minus 2x because everything stayed the same except for the length and width changing. Width becomes 38 minus 2x, and the height is still x. So our volume equation is still 50 minus 2x inches times 38 minus 2x inches times x inches. Now, I decided to create another semi-chart, plugging in random numbers in, and I just wanted to go all up to 7. And as you can see, I plugged in 1, 2, 3, 3.5, 6, 7, 8. And for 1, I got 1,728 inches cubed. 2, 3,128 inches cubed. 3, 4,224 inches cubed. 3.5, 4,665.5 inches cubed. 6, 5,928 inches cubed. 7, 6,048 inches cubed. And 8, 5,984 inches cubed. So now we know what to look for the max. It's between 7 and 8, because 7 is the max we have from all these numbers here, and 8 is when it's starting to decrease. So we know that the max number has to be between 7 and 8. So I did this again. 7.1, 7.2, 7.3, 7.4, 7.5, 7.7, and 8. So from here, plugging in 7.1, I got 6,049.484 inches cubed. 7.2, 6,049.152 inches cubed. And 7.3, 6,047.028 inches cubed. 7.4, 6,043.136 inches cubed. 7.5, 6,037.5 inches cubed. 7.7, 6,021.092 inches cubed. And lastly 8, which is 5,984 inches cubed. So, from here, we can clearly tell that the max volume size is 6,049.484 inches cubed. And that's from 7.1. 7.2 was a really close number too, but it wasn't the max. So, now that we have our x, we plug it back into the length and width equations. So, 50 minus 2 times 7.1 gives us 35.8 inches for our length. Width, 38 minus 2 times 7.1 equals 23.8 inches for the width. And because height equals x, and x was 7.1, our height is 7.1 inches. Now, the length times width times height is our volume. So, plug in the numbers again. Length of 35.8 inches, the width 23.8 inches, times the height 7.2 inches, or 7.1 inches, sorry. Which gives us 6,049.484 inches cubed. And that's it. Thank you.